So the next thing we want to do is get this bar showing actual audio and scrolling as well, so we get the graph kind of showing real audio. You'll notice on the Boolean loudness meter though, that when we talk, if I just go silent and then say peak and then wait, you'll see how long after the fact that audio stops that this bar kind of digresses. Peak. And you can see that drop there. Takes a long while after saying peak, so it's not necessarily just a direct correlation, so we'll have to figure that out as well. So the first thing is getting the graph to scroll. Now we saw in the example before, if we look at lines auto update and click constant change, you can see the graph kind of updates and scrolls. Now this isn't scrolling, and we do have, I believe in step lines auto update, you can see that this would scroll. And I'm not sure what that is yet for that one, but I also can't find an example in code here for the update. So we'll just start with this auto updating example instead. So we pull up the code that we're currently working on. The first thing we'll need to do is update the series to have values that are observable, otherwise we can't change them. And at the moment we just have a list of static doubles. And you can see here what they do instead is make an observable set of values in the view model and then alter those. So we're going to do the same thing, and it's just basically an observable collection of observable values. And so we'll have a public observable collection of observable values, and I guess we'll call this main chart values. And we'll just new up the collection. And then the values here, they want to go, and that wants to be the main chart values. And the line series type, instead of double, needs to now be observable value. And I believe that should bind in. And it can't access non-static field, and that's because we are newing this up directly here, which we should probably then do outside of this creation here. So we'll do that in the constructor. And you'll see there's two constructors, and we've made an initialize function. So now it's time to use that initialize. Here we can now set the series, which is what we've removed it from, and we should be able to access that value. So let's just check that still works. Now we've just tweaked those few things, and we probably won't know because we haven't now added new values. This main chart value doesn't have anything, but it's still compiled and showed. So let's now just make the main chart values dot add, and let's just add some values. See here, because it's expecting the type that main chart values is, which is an observable value, we can't just do the values we used to do. We'd have to do new observable value and then the value inside. As of C#9, however, you shouldn't need to specify the type of object. You should just be able to do this new with open parentheses. So if we then just did this again, and for quickness we don't really care, let's just do a few values just to see this is working. That'll do. Nothing special, let's just see if we actually see values. And there you go, so we now have the same thing we had before, just that we have an observable collection that we should be able to modify. So next let's take a look at what they do in order to do this kind of fluent animation. So they've done this where they've just newed up the enumerable values. They've added it as values here, which we've already done. And you can see toggle constant change sets is streaming to true or not true. And then basically it removes an item, adds an item, and waits 100 milliseconds. So we need to see what we do with remove and add. Removing, if there's more than one value, remove at index 0. So it'll remove the first item in the list, it'll remove this one. And then the add item, I presume, will add an item. So it adds a random value to the end. So what it's going to be doing is removing one at the start and adding a new one at the end, which you can see there animating nice and slowly. So if you watch this disappear and then one get added over there, and you can actually do this live on the lines auto update. So we should then see this one disappear, this one add. And I guess that's what you're kind of seeing here, where the dots appear and disappear over time and they're getting added there. So let's see if we can repeat this thing. So effectively it's doing remove item like that and then add item like that. So it's doing the equivalent of us just clicking this over and over, and you can see that's the chart kind of animating like that. So we'll just temporarily chuck in a private, don't really need to put it all the way up here because it's literally going to be temporary, but let's just do private random, a new random number generator. Not going to comment because this is going to be gone once we prove it. And then we need some kind of repeating event. So let's do when we process audio. We will now do, shall we do the main chart values, wasn't it? Yeah, remove at 0. And then the main chart values dot add. And we want the mrandom.next. We'll have it between 0 and 60. And that needs to be an observable value. So we just have to put it inside of its own parentheses like that. And I think that will work. And you can see going incredibly fast but then crashing. So that will be obviously too fast for our update. And we should also do this on the dispatcher UI thread. Otherwise we are not correctly on the UI thread. We are, even though we're in an observable collection, it clearly doesn't like doing this off the UI thread. So you can see that that works now. It's just incredibly fast at moving. So we can, and then obviously crash when we close it because we've cancelled and the thread just disposes. Instead of doing that, don't bother removing and just add a random value all the time. And I guess this will quickly stack up though. And you can see there the random values adding, and that's just going to continue to add over and over. So you can see we have the chart. So next, it won't be that hard to, let's move this to processing. Process audio chunks. Let's go inside this, I guess, maybe. So we're updating at the same speed as everything else. Kind of makes sense. We'll break off to the dispatcher thread and we'll add the item there. But now all we've got to do is work out the value of the real audio and chuck it in here. So we could just do audio data.short-term loss, and let's not forget to do the main chart value.remove at 0. Put that back in, and this should give us real audio. It's probably not in the right value. I think we've got to invert it or do something with it, and it's just disappeared. Well, it was on there and then just rapidly vanished. That will be because it's a minus as well. So let's just double minus it to get it back to positive. And then I think it'll just need inverting. And that's, yeah. So we're kind of there, but we're not. It's doing this weird glitchy, but we don't have many items in either. At the minute we have, how many did we add? We added like 5 or 6 items. So instead of doing this, let's just populate this with, can we do add range? Yep, add range, do an enumerable, dot range, and it is 0 to say 200. Oh, and I need to actually select that. Convert that to the new observable value, and we'll just put zeros in. So it'll be flat at the start. We'll have 200 blank items, and then the new value should scroll in. And there we have some values, and I presume that's the audio, but it's obviously needs inverting. So let's just pause and find out what that value is. So yeah, minus 66, which is way off. It's literally silence basically. That's probably me not talking. Then if I keep talking, I guess that value will increase. There you go, to like 54. And if I keep going, I don't know how far behind we are now. But I'll tell you what, if I remove that, and then I keep talking loud and then pause while I'm talking, you can see minus 37. So that would be 37. So that's right, but it now needs to be in the right range. And to do that, the value will be the maximum. You don't want to go negative, so you want to be at 0 if it goes negative. You want to be 60 plus the negative audio value, so it will effectively become a minus because it's already a minus. And that should now, I believe, be in the right range for the actual audio. And now if, there we go, that's me talking, and it should mimic this bar here, this white bar. So wherever this white bar is at the moment in time of talking, this graph should mimic. And you can see if I go silent and let it drop, that it does. So that's now actual live audio. And I obviously record the audio quite low at the moment to keep peaks at a high, so I can obviously edit this post-processing. So normally your audio would expect it to be up here. But you can see even in the Ulian loudness meter, we're at a similar level. We're nice and low at the minute. That's just how I'm recording this specific video. And you can also see the update speed seems to be roughly the same as well. We have an extra bar over here we don't want, like there's something missing over here, so we'll have to fix that at another point. But you'll notice that when we talk on the Ulian loudness meter, it's got nowhere near this many alterations and waves and instant changes. It's actually this arrow it follows. So you'll see on the Ulian loudness meter, this arrow stays somewhere, whereas our arrow at the minute is just a fake following of this value, but less. So I believe that's more of an averaged out signal, but there's also some kind of delay going on. So once I stop speaking, this line here, you'll see, stays high. So watch this, stop now. And see how much longer it's only just stopped here, whereas ours stopped immediately. So we talk on ours, it goes up, you stop talking, and it's dropped. So it's instant drop. So that's how that works. So we need to do a delay first, I believe. And to do that, we'll just do the same as we did already in the capture. We just did a queue. So we just did this queue here and kept a delay. So I don't know whether to make this its own little mini class for a buffer. I mean, it's not that, to be honest, it's not that much work at the minute to, I think, warrant that. So we'll just go and chuck it in the private members for now. We'll get rid of the random and we'll do a new LUFS here, a buffer in the view model, which actually now that's starting to split the requirements. Let's keep it in the audio service. I think we'll keep it in here, and we have LUFS, and we should have then, I guess, chart LUFS, so it's a different one. Otherwise we're going to start mixing audio logic with the view model, which is something we shouldn't be doing. And then what we now need to do is move this logic firstly, so the main chart values, actually this shouldn't change, this is literally just adding the chart values. But this value, the short-term LUFS, needs to be another one. And again, this is the same because this is relevant to the chart. We're making a chart that's specifically in the 60 decibel range. So this stays, we just need to now move this value, short-term LUFS, and we need a new one. So let's just do, we haven't actually used loudness, so maybe we'll purpose loudness, or have we used it? Do we use it anywhere? No, we don't use loudness at all. So we could purpose this loudness chunk, but I thought we would have, when we set it, yeah, we set it to average LUFS, which I guess that shouldn't be average LUFS, that should be really the direct LUFS, so the unedited instant changing loudness. Let's make another one now, which, and actually saying that now, let's do what we said it should do. In the Ulian loudness meter, this arrow is the value that we want in the chart. And if we look at the graph here, it is actually short-term LUFS. Short-term LUFS is this arrow, and this inside here is more of the instantaneous audio. So we need to flip ours around so the definitions are right. So short-term loudness in our view is actually short-term loudness, which is right. But you have the arrow and the bar. So the arrow wants to be short-term loudness. So we've got volume, percent, position. And we've set that here. So this wants to be short-term LUFS, not that. And the volume bar, which is the instantaneous one, wants to probably be loudness. So we have all the values we need, we just need to now update the actual short-term LUFS to be not average LUFS, it wants to be the new value, which wants to be an even more delayed LUFS to start with. So let's do the same thing here, chart LUFS and queue, limit queue sizes, And the other one we'll do like 30, wants to be like 3 times slower. Then the average LUFS is the average LUFS. The short-term LUFS wants to be the average long LUFS, we'll call it. And then, to be honest, chart LUFS probably wants to be renamed to just, if I could actually rename, why can't I rename F2? LUFS longer. Average long LUFS and short-term LUFS is that. So let's see now if we get anywhere with the short-term LUFS looking similar. So now you can see this bar is now live, which is a bit too much. That's like crazy, like instantaneous live. So possibly we do want to ignore the instant LUFS here, and we do just want the average, the short-term average. I don't think you want that crazy fast update on the screen. So there you go. So now LUFS is actually live, and you can see this arrow is actually following behind. And it looks similar to this, but we've now got to get our LUFS, the short-term LUFS, being a lot more delayed. And that would mean our graph would also be delayed. So we just need to work on this short-term LUFS specifically. So as well as the delay that we need to work on, this kind of delay, if we just put a bigger delay in, let's see what happens. If we just put like 100, this should, in theory, have a very long delay. But we've also got an average, which I'm not sure whether it's an average. Yeah, so you can see the arrow is really delayed both before and after. So you get this very slow slope of audio averaging. Whereas if you look at the original, if I stop speaking and then do a peak, you can see it instantly rises immediately and then takes time to fall. Whereas on ours, peak, you can see if I do peak, it doesn't even go up. You have to continue to talk. So I think the difference there is maybe it's just a max. There's probably a lot more math going on than we know of, but let's say the average long, the longer LUFS, let's do a max instead of an average. And let's see what should happen there, because at minimum that will give us an instantaneous rise. Peak. So there you go. Now you can see ours peaks immediately when I talk. That was that peak, and then let's see how long it takes until it falls. So that's pretty much the same as over here. I don't know if I can get them both in the same frame, but if we watch now, if I'm talking, ignoring the values being different levels, watch until this falls and when this falls. So you can see they're similar in when they fall, and now when I talk they instantly rise. So that's a similar shape. I'd say ours is a lot more sort of square. So you can see theirs is wavy and not really square. This is a very much, which you'd expect in a way, because we're using a max value and then a massive delay. Oh, that's a point, we've got the massive delay on still. Let's change this now to like 30 to get a less average. And now we should be able to see when I'm talking, that's a much smoother curve now. That's got more detail in the shape now. I'd still say it's quite square. It's like sort of an average square. But this is clearly audio. And then this arrow here you can see moving. But again, it's very sort of snappy. Whereas if you look at this one, it takes longer to fall. A lot longer. And it's also smoother. So I think there's some kind of combination going on here where we probably need to balance the difference between the delay and the fact that the chart's actually showing something of use. So the chart's very much, like I say, a kind of square. It doesn't change, and that's because it's taking what we say and adding it to an average. It's clearly something to do with the max, so that when you talk it instantly rises. But you can see this has a lot more detail. So this can't be just an average or a max, because this is changing all the time, but then when you stop talking, this kind of level remains. So there's a bit more math to do, whereas ours is very much just a square chunk of average and then maxes. So, you know, it's not really working. I don't know whether it's just going to be an average, but when there's a volume maybe higher than the average, do you just maybe increase the overall average? Or, do you know, there's something going on with the calculation. And if we change the max back to average, I think you get a much nicer chart in essence, but the only difference is the peaks need to rise quicker. So if we do average and now we talk, you can see this is definitely a lot more where I'd expect an average to be. But it's sort of, you know, let's ignore the peak, say, and let's just go for talking on average. And let's do, say, 200 in the queue. Let's make a very long delay in this average. And let's see if we can get it looking similar to the Julian loudness meter. So now we've just got a really long average. That definitely looks a lot closer to the Julian loudness meter. So if we start talking now, despite the slow rise here, which I think is the difference, this chart now looks a lot more like this chart. And then if we stop talking, it's the initial rise and the final fall that's mostly different. The middle is definitely this kind of average. We need to do something when there's a period of quiet that it pulls quicker. And when there is an initial spike, it's instantly risen up. So almost like the peak has to push the peak up rapid. It needs to get to max volume minimum. And then after that, it kind of tapers off in another way. But this chart's now much more accurate. So it's definitely something to do with the average. What can we do for the peak? So we've got the averages, we've got the Q. I don't know whether when do we just, when we're talking and something goes above the average, do we just clear the Q and make the average the max? I don't know. So let's say if LUFS, which actually you've got the main one coming in, just the LUFS on its own. But the LUFS average is fine. So I'd say what if the average LUFS is greater than the average long LUFS? I reckon then we just clear. Let's just try it and see. LUFS longer dot clear. Let's clear the whole queue and add back what we originally added, which was the LUFS. And in this case, we will add the average LUFS back because it's already done for us. And let's just see. God knows what that'll do, but let's see. So now when we talk, we have the instant rise. But it's now gone to... that's probably hitting every time, actually. Yeah, so average 68, 68. We're clearing the queue. So that's actually going to hit almost all the time. So the queue's always clearing. Yeah, so every time it drops and peaks, you're just wiping out the average all the time. So you can't just do that. So what about the average LUFS? Let's say it's got to be a certain value above. And now, do we get a peak and then a steady rise? And I think we actually do. So if I keep talking a minute, keep a breakpoint on that. Now, the only time this... there you go. The only time this should hit is when I talk significantly louder. Peak. And then you've got your peak. And you've got your instant fall. So now we have an instant peak. And then when I'm continuing to talk... yeah, so not enough still. So let's make that bigger. So now a small peak is still a rise. And this shouldn't be now engaging this, which it isn't at the minute. Peak. And now it's too quiet. Yeah, so we have to talk a lot. So we can do this kind of concept of whenever the average, so whenever we're talking and it's louder than the average by a significant amount, we clear the queue and bump it up. But that's not, you can see how it goes very spiky once we do that. We lose the average. So I think instead of just clearing the queue, we need to enqueue this 30 times. So otherwise the queue is going to be 1 in size and not 30, so the average doesn't last. So you want the queue to still be full. You just want it to be full of the average. So let's just fill it by doing while LUFS longer dot count. Oh, and actually it's 200 we did now, isn't it? So less than 200. Just NQ. And this will kind of clear the average and reset it. So now when we're talking, there we go, it's bumped up, and then it's like now an average of talking, although it's going down considerably. And if we compare that to the Julian loudness meter now, you can see we've got some weird spikes. It goes up, but it instantly drops down. So as soon as we've done the peak, the average then starts falling again. Yeah, so you're getting the peak rise now, but you're getting a sort of a very much sawtooth up and down every time we talk over, as opposed to smooth. So maybe change how many of the averages we put in, and maybe also only remove so many. Maybe we just go backwards and effectively overemphasize the peak. So that's now when we're talking. If we continue to talk, you don't want to see it falling, which you kind of still do, and then you get these peaks again. Yeah, so it's still too much. So instead of clear, let's just do while LUFS is, I don't know, let's say just remove 50 of them. So while it's greater than 150, because it'll nearly always be full, we'll just do LUFS longer dot remove DQ. And then while it is less than 150 or less than 200, when it's less than full, we add them back in. And now let's see how that behaves. It pumps it up and continues to almost be there, but you're still getting this sawtooth thing, and you're never seeing that in this loudness meter. You're never getting a sawtooth as such. So now when we start talking, you get the rise, and if I maintain my voice at the same peak, you kind of see that it's still dropping below constantly. So it's not exactly keeping it where it should be, it's always dropping below, and when I talk above, it's still not peaking. And that's probably because that is too high. So let's change that. Testing, 1, 2, 3. Let's see if I continue to talk. Does this match in any way the behavior we see on the Julian loudness meter? I think we're still seeing very much a sawtooth pattern, as you can see here, which never happens before. So I don't believe that's the correct way to go. This is a lot smoother. So I don't believe that's the correct math to do this. And I don't think it's that big of a problem right now, because this is not something that is specific to what we're trying to do. The kind of audio processing and math, as we know, is a lot more of a complicated subject. So I'm going to be happy with, I think, using the average. If we compare these two, you can see when we use the average, ignoring the gap in the calculation slightly, you can see the overall shape now is the same, and as we're talking, everything kind of moves and looks very similar. The speed at which they're moving is the same. The difference is when we stop talking or start talking, this tapers off as a pure average, and the Julian loudness meter has harsh starts and ends. So you see the difference there between the harsh drop off and the rise, and you can see the very much smooth and fully averaged one of ours. But that math we can leave to anybody to do, anyone that knows the audio world, or we can come back at any point. It doesn't affect the graph or how this works at all. So we'll be happy with that for ours, knowing the difference. We now have the bars doing the correct thing. We have a graph moving. We'll probably want to change this overlay. You can see how this is just a series 1, and this has got like a custom line. I quite like, to be honest, this style versus that, because you're looking here, but then you have to look up the top. So I kind of like this this flow. So I'll probably just tweak that to add this information. We also need, ideally, this bottom graph to be a time frame, which we should be able to do because the graph did support it when we looked. We had a scrolling graph. But overall, I'm happy with that now. We have a working graph, and we can move on to the next things. So we're finally getting somewhere now with real audio and showing on a graph. And I guess we can do this graph next, this sideways graph, which I'm not sure what it is, or this bottom one. Or we can leave those two out now and move on to other things. We have the majority of this app working. We have what we wanted, which is values in here that can be altered. We have a live graph, we have buttons. Depends how far we want to take this, because we're not really going to replace this application. You know, we could just keep going and doing all these menu settings, or we can jump on next onto making an actual mobile and full cross-platform application. This has been a good introduction to Avalonia. but they do support full mobile development, and we're not really doing any of that at the minute. So let me know, guys, whether you want us to just continue fleshing out this UI and continue more and more, or come back to this at any point in the future and let's jump onto some mobile application and desktop application, a true cross-platform application where we can start doing mobile app development instead of just desktop applications. So that's it for this one, guys, and I'll catch you in the next.